Welcome to Colonize the Ocean podcast, where we discuss oceanic colonization, exploration, and education with your hosts Adam Jewell and Brendan Traxler.
Welcome to the deep dive. Today we're plunging into a world that feels incredibly remote, almost alien. A place of just immense pressure, total darkness, and ecosystems that sound like something out of science fiction.
Yeah, it's funny. We often compare it to outer space, right? In terms of mystery, how hard it is to get to. But this realm, it isn't light years away. It's right here on our own planet, just beneath the waves.
Exactly. We're talking about the deep ocean.
And that comparison to space, it's actually more accurate than a lot of people might think. When we talk about the great unknowns, our minds usually jump to the stars, to galaxies far away. But think about this for a second. Over 80% of Earth's oceans are still unexplored, unmapped, unknown.
It's staggering, isn't it?
It really is. We literally have, better maps of the surface of Mars than we do for huge parts of our own planet's seabed.
That statistic always gets me. It just hammers home how much is left to discover right here on the planet we live on. And, that incredible sense of mystery, that vast unknown, that brings us right to the heart of this deep dive. We've got this really fascinating article here from Sustainability Times. It lays out a plan that's frankly so ambitious, so technologically challenging, that it just immediately makes you think of venturing beyond our atmosphere. The source itself actually calls it a deep-sea space station.
That's right. And that's our mission today, really, to take this article, the stack of information from Sustainability Times, and just meticulously unpack it. We need to understand, what is this project? What's the scale of the engineering involved? What are the big scientific goals they're trying to achieve down there in this uncharted territory? And importantly, we also need to look at the complex geopolitical stuff that's kind of swirling around where they plan to put it.
Yeah, the source really frames the whole ambition perfectly, using that term, deep sea space station. It sets the scene instantly. It highlights the huge technical challenges, the potential for really groundbreaking discoveries. It mirrors space exploration in that sense.
It does.
So this isn't just, another research lab. The article suggests it could fundamentally change our ability to do deep-sea science. And like you said, it touches on some pretty significant global dynamics, too. Okay, let's unpack this.
Let's dive deep.
All right, so let's start at the beginning. At its core, what is this project? What does the source actually tell us about this concept?
Okay, so fundamentally, it's a plan to build a permanent research station, manned, deep underwater. The Sustainability Times article calls it a highly advanced underwater installation. And it also labels it, and this is important, one of the most complex ever attempted.
One of the most complex ever attempted. Wow, okay, that phrase alone tells you a lot. And the specifics the source gives us really underline that complexity. The depth they're talking about is just mind-boggling, isn't it?
It really is. The article specifies an operational depth of 6,500 feet below sea level. 6,500 feet. We should probably pause on that number for a sec.
Yeah.
That's over 1.25 miles straight down into the ocean. Just to give you some perspective, a lot of the current crewed submersibles, even the advanced ones, they might visit those depths, but staying in there for extended periods, that's a whole different ballgame. This is much deeper for a permanent or semi-permanent human presence.
Right.
Building a habitat that can actually withstand the crushing pressure down there, that's a massive engineering challenge. Huge.
I mean, the pressure at 6,500 feet, what are we talking? Something like 3,000 pounds per square inch, is that right?
Roughly, yeah. It's immense.
It's like having, several large cars pressing down on every single square inch of the structure, the materials you'd need, the structural design, just figuring out how to power it and maintain normal air pressure inside.
Yeah.
These are problems on the same scale as building spacecraft, basically.
Exactly. The source doesn't go into, the specific alloys or the blueprints, obviously, but just stating that depth, 6,500 feet, immediately tells you this is pushing the absolute limits of current engineering. The structure has to be incredibly strong, but also needs to house people, delicate scientific equipment safely, comfortably, for weeks at a time.
And speaking of time, the timeline mentioned in the source is also well, pretty ambitious, right?
It is, yeah. The article says the station is set to be operational by 2030.
2030.
Yeah. So given the complexity we're talking about, getting something like this up and running in, what, the next 6 years or so?
Yeah.
That's a very aggressive schedule.
Definitely. And the location, where does the source say this is all supposed to happen?
Okay, yeah, the planned location is the South China Sea.
Ah.
And this is a really critical detail that the article keeps coming back to. Because as you can imagine, it brings in some major geopolitical factors that we absolutely need to dig into later on.
Understood. Yeah, we'll definitely circle back to the implications of putting it there. What about the station itself? The scale, the capacity? How many people are we talking about living and working down there, and for how long?
The source says it's designed to house up to 6 researchers at a time.
6 people. Okay.
And critically, these aren't just quick trips down and back up. The plan is for month-long missions, 30 days or so at a time.
So, okay, a small team of scientists living and working completely cut off at extreme depth for weeks on end. This is where that deep-sea space station comparison really lands, doesn't it? The source explicitly makes that link.
It does, yeah. The article mentions it, providing research opportunities reminiscent of the International Space Station. Think about the ISS, right? It lets scientists live up there in orbit, doing experiments that need microgravity or long-term observation. Stuff you just couldn't do with short shuttle flights or robotic probes alone.
Right. You need people there long-term in that unique environment.
Precisely. And the parallel the article draws is that this deep-sea station aims to do the same thing, but for the deep ocean, providing that persistent human presence in a totally unique, extreme environment right here on Earth.
So the challenges are different, immense pressure and total darkness instead of vacuum and radiation, but the core idea is the same. Create a safe bubble in a hostile place so scientists can do long-term work.
Exactly. The source uses that comparison to really emphasize the potential scientific payoff and just the sheer engineering scale of it all. It's about setting up like a base camp in Earth's inner space, enabling the kind of sustained, deep research that quick visits just can't achieve.
And the initial reaction as presented in the source kind of frames this project as, well, as proof of China's growing expertise in marine exploration. It calls it a technological marvel. It seems the article views it as a landmark achievement just on its own terms, even before you get to the science it will enable.
Yeah, it's definitely presented that way. As a major statement of technological prowess and ambition, building something like this successfully would demonstrate really advanced capabilities in materials, in robotics, life support, navigation, deep-sea construction, the whole package. It positions China as a leader in this really specific, really complex area of exploration.
Okay, so beyond the impressive engineering feat itself, how does the source explain the impact this station will have? How will it revolutionize marine science and exploration? What are the limits scientists face now, and how does having a permanent base like this change the game?
Well, the article really emphasizes that current deep-sea exploration is, frankly, severely limited. Think about the tools we have now. Crude submersibles like the famous Alvin or even newer ones, they can only stay down for a handful of hours.
Right. Battery life, life support.
Exactly. And even just the physiological strain on the people inside. Robotic subs, ROVs, they can stay down longer, sure, but they don't have the flexibility, the on-the-spot thinking and analytical capability of having human researchers right there.
Makes sense.
So trying to, say, recover delicate samples or set up really long-term experiments or just observe processes that unfold over days or weeks, it's incredibly difficult, sometimes impossible, with current methods at these kinds of depths.
Oh, okay. So it's not just about getting there, like you said before. It's about staying there and being able to work continuously.
Precisely. That's the key point the source highlights. Maintaining a continuous human presence at 6,500 feet allows for, and I'm quoting here, systematic, ongoing research programs that are currently unattainable. So instead of just getting brief snapshots from short dives, scientists could establish long-term observation posts. They could monitor changes across seasons, run experiments, adjust them based on what they see, respond to unexpected events in real time. It's much more like how researchers on the ISS can study things over long periods.
That shift from just visiting to actually living there, essentially. Yeah, that sounds genuinely transformative for the science. The source even makes another really powerful comparison to drive this home. It suggests this underwater station could revolutionize deep-sea knowledge in the same way the James Webb Space Telescope transformed our view of the cosmos.
That's a very bold comparison, definitely. But I think it speaks to the potential scale of discovery they're hoping for. Think about the Webb telescope. It didn't just give us slightly clearer pictures, right? It opened up whole new ways of seeing the universe, new wavelengths, incredible sensitivity. It let us see things, phenomena, galaxies that were literally invisible before.
Right, a fundamental shift in capability.
And the source is suggesting this deep-sea station could offer a similar leap for ocean science. By providing just unparalleled access and observation time, it might reveal fundamental processes, maybe entire ecosystems, geological features in the deep sea that we can't even imagine right now, based on the tiny glimpses we get. It's about moving beyond educated guesses based on limited data towards direct, long-term observation and hands-on experimentation.
And it brings us back to that mind-blowing statistic again. Over 80% of our ocean's unexplored. The article really frames this project as a pivotal step in finally starting to tackle that vast unknown, Earth's final frontier, as they put it. It's like, finally setting up that permanent research base in Antarctica decades ago, or maybe like the long-dreamed-of moon base. It provides the infrastructure you need for a really sustained, in-depth exploration of a super challenging place.
Yeah, it's about building the foundation to go from just scouting, basically, to doing comprehensive long-term study. And the article makes it clear this isn't just going to be one isolated habitat floating down there. It's designed to be part of a much bigger integrated system.
Right, yes. The source mentions it working together with unmanned submersibles, specialized ships on the surface, and fixed observatories planted on the seabed. They call this whole setup a comprehensive four-dimensional monitoring system. What does that mean exactly?
Well, that integrated approach seems key to getting the most scientific bang for the buck, so to speak. The station itself provides the human intelligence, the dexterity on site, the ability to react, maybe fix things, run complex experiments that robots struggle with.
Okay, that's the human element.
Right. Then you have the unmanned subs. Maybe they're launched and recovered directly from the station. They give you mobility to explore wider areas away from the main habitat.
Got it. Extending the reach.
Exactly. The surface ships are crucial for logistics, for supplies, communications back to land, and probably for deploying other larger equipment.
The support network.
And finally, those seabed observatories. These are fixed instruments left in place, maybe for months or years, continuously measuring specific things. Temperature, pressure, water chemistry, seismic activity, whatever you need. They provide that long-term context, the time dimension.
Okay. So you've got the real-time human presence, that's one dimension, then the mobile robotic exploration covering the 3 dimensions of space around the station, and the fixed sensors adding the 4th dimension, time. Combining all that gives you a much more complete picture.
That's the idea. The source says this integrated system will significantly boost data collection capabilities. It allows for a much more exhaustive analysis of these really complex deep-sea environments. It's not just about grabbing a few samples here and there. It's about understanding the dynamics, the processes that shape these ecosystems over time and across space.
Okay, so we have this engineering marvel, the ability for people to stay down there, and this integrated system for comprehensive data gathering. What specific science does the source say they'll be targeting with all this capability? What are they hoping to study first?
The article gets pretty specific on this. It identifies one of the main research focuses as cold seeps.
Cold seeps. Okay, I've heard the term, but what exactly are they, according to the source?
So the article describes them as these unique spots on the ocean floor where fluids rich in hydrocarbons, think methane, mostly, or other chemicals, seep out from beneath the seabed. It makes a point to distinguish them from the more famous hydrothermal vents, right? Those are linked to volcanic heat and spew out super hot sulfurous water.
Right, the black smokers and white smokers.
Exactly. Cold seeps, as the name suggests, involve fluids that are much cooler, sometimes near the ambient water temperature, but they're loaded with things like methane gas or even oil. Think of them more like underwater natural gas or oil springs rather than hot volcanic vents.
Okay, interesting. And why are these cold seeps considered so important scientifically? What's the big deal about them?
The source points to a few key reasons.
Yeah.
First, and maybe foremost, they're described as biodiversity hotspots.
Hotspots, even down there in the cold and dark.
Yeah, surprisingly. Despite the extreme conditions, crushing pressure, total darkness, no sunlight for photosynthesis, these seep areas support incredibly rich and often unique ecosystems. Life there isn't based on sunlight energy. It's based on chemosynthesis.
Chemosynthesis, using
Right.
chemicals for energy instead of light.
Exactly. The organisms there have evolved to utilize the chemical energy in the methane, or maybe hydrogen sulfide, that's being released from the seep.
Wow, so completely different food webs, different energy sources driving life down there.
Pretty much. And the article suggests that studying these ecosystems could unlock secrets to deep-sea biodiversity. They might find entirely new species, maybe bizarre symbiotic relationships between microbes and larger animals, novel biochemical pathways that organisms use to survive in these extreme conditions.
Fascinating.
The source compares them to the hydrothermal vents again, which are also famous for hosting weird and wonderful life forms. It highlights cold seeps as these biological hotspots that really warrant extensive study. Imagine discovering microbes that produce unique enzymes or understanding how complex life can thrive without any input from the sun. The potential for fundamental biological breakthroughs seems immense.
It really is like potentially finding entirely new branches on the tree of life hidden away in these pockets on the ocean floor.
That's a great way to put it.
Yeah.
And the significance, according to the source, goes beyond just discovering new creatures. It also touches on potential resources and even environmental applications tied to these cold seeps.
Okay, resource potential. That definitely catches the ear, especially when we remember the location we talked about earlier.
It does. And the source is explicit about this. It notes that these sites could offer insights into renewable energy solutions through their unique gaseous properties. Primarily, the methane itself that's escaping from the seeps is, well, natural gas. It's a potent energy source.
And the article actually gives a number for this potential resource, a pretty huge number.
Yes, it does. It states that the methane deposits associated with cold seeps globally might represent something like 70 billion tons of untapped resources. 70 billion tons.
Whoa!
That's an enormous figure. The source describes this as offering significant energy potential. Now, actually getting that methane is often locked up in structures called methane hydrates, kind of like ice that traps gas under pressure, is technologically very challenging. But the sheer potential scale of the resource makes these areas incredibly interesting from an energy standpoint.
70 billion tons. Yeah, you can see why that figure would capture the attention of nations thinking about energy security.
Absolutely. It underlines the fact that while the stated primary goal might be pure science, the potential for understanding and maybe eventually accessing significant energy resources is clearly also part of the motivation, and it's something the source makes sure to highlight.
And then there was also an environmental angle mentioned in the source, something about remediation.
Yes, this is another really interesting potential benefit. The source suggests that microorganisms living in these cold seep environments could lead to breakthroughs in environmental cleanup. Think about it. These are microbes that have evolved over millions of years in places naturally saturated with hydrocarbons, with oil and gas.
Ah, so they might be naturally good at breaking down those kinds of compounds.
That's the idea. The article suggests they could play key roles in naturally degrading pollutants, and it specifically mentions oil spills. So by studying the unique metabolic processes of these deep-sea bugs, we might discover new enzymes or pathways that could be harnessed for bioremediation using biology to clean up contaminants. Maybe techniques that are more effective or work better in the cold, high-pressure marine environment than current methods.
Okay, so these cold seeps aren't just scientific oddities or potential gas fields. They might also hold keys to cleaning up human-made pollution. That really highlights the multiple layers of value the source sees in focusing research here. Unique life, energy potential, environmental solutions, all possibly stemming from these deep-sea leaks.
It definitely makes the choice of cold seeps as a primary research target seem very logical from both a scientific and potentially an economic perspective. The potential payoff for investing in a facility like this could be significant in several different areas.
Now, the Sustainability Times article, it doesn't talk about this project in a vacuum. It makes a point of placing it within the wider context of China's overall technological and scientific goals.
Yeah.
How does the source frame the deep sea station in that bigger picture?
Yeah, the article positions this as a really key piece within China's much broader and quite substantial investment in advanced deep-sea technology generally. It suggests it's not just a standalone project, but part of a bigger strategic push to develop world-leading capabilities in this specific domain, and that this push complements advancements China's making in other high-tech fields as well.
Right, and the source actually lists some of these other fields, doesn't it? I remember seeing mentions of things like quantum computing, huge renewable energy projects, advanced satellites, even nuclear fusion research.
That's right. The article references that whole array of other high-profile projects, quantum computing breakthroughs, massive solar and wind farms, new satellite constellations, experimental fusion reactors like the East Tokamak. It uses these examples to illustrate what it calls China's growing portfolio of cutting-edge scientific initiatives. Interestingly, it also throws in mentions of a colossal drilling machine and aircraft carriers in the same context.
Those seem a bit different from pure science projects.
They do.
Right.
And while maybe not directly related to marine biology, the source seems to include them as broader indicators of China's rapidly advancing technological capabilities and its ambitions across many domains: fundamental science, energy, infrastructure, even defense and resource extraction.
Okay, so the article is basically painting a picture of a nation making really significant, coordinated strides in technology on many different fronts. And this deep sea station is presented as a very visible, a very ambitious part of that overall strategy for tech leadership and scientific discovery.
Exactly. It's framed as part of a national drive to become a global leader in science and technology, and deep sea exploration is clearly identified as one of those key strategic frontiers. And focusing back specifically on the deep sea, the source really emphasizes what this station represents in terms of human capability in that environment.
It says it's a significant leap in human capacity for deep sea habitation.
Yeah, and that phrasing, human capacity for deep sea habitation, is important. There have been underwater habitats before you think back to the U.S. Navy's Sea Lab experiments in the 60s and 70s, or the Aquarius Reef Base, which is still operating but at a much, much shallower depth.
Right. Those were pioneering but different in scale and depth.
Very different. The article acknowledges those past efforts, but really stresses that this proposed facility, being permanent or semi-permanent at 6,500 feet, enables systematic, ongoing research programs at unprecedented depths on a scale that just wasn't achievable before. It fundamentally changes what scientists can do down there because it allows them to live and work there for extended periods rather than just making these brief, challenging visits from the surface.
This really brings that comparison to setting up a permanent base on the moon or Mars back into sharp focus, doesn't it? It's about establishing that persistent human foothold in a place that was previously almost entirely off limits, incredibly hostile, to enable exploration and science on a completely new level.
That's definitely the level of ambition that the source attributes to this project. It's about opening up a new operational domain for humanity right here on Earth.
Okay, now, we absolutely have to circle back to the planned location. The article is very direct that putting this project in the South China Sea raises some significant geopolitical issues. And like we said, this is where things get sensitive. Our job here is just to report what the source material tells us about these tensions and the potential impacts without taking any sides ourselves on the underlying disputes.
Absolutely critical to maintain that neutrality. So the Sustainability Times article highlights that the South China Sea is a strategically significant region. That's the phrase it uses. And it points out that China's territorial claims there are contested by several other nations. It specifically names Taiwan, Vietnam, Malaysia, Brunei, and the Philippines as having competing claims in the area.
So based on the source, the station is planned for a spot that's right in the middle of a highly disputed maritime area.
That's what the article indicates, yes. And the source is quite blunt about the potential ripple effects of this. It states clearly that these ongoing disputes could potentially impact the project's development timeline. So it's acknowledging that the political climate isn't just some abstract background noise. It's a real-world factor that could cause delays, complications, maybe even risks for the construction and eventual operation of the station.
And the article draws a direct line between the station's scientific goals, especially researching those cold seeps we discussed, and these geopolitical disputes, right?
Yes, this is a really crucial connection the source makes. It explicitly states that the valuable hydrocarbon and methane deposits, the very things the station aims to study at the cold seeps, are themselves part of the contested resources in the South China Sea.
Ah, okay, that adds a whole other layer.
It really does. It means the scientific work and the potential economic value derived from understanding those resources is directly linked to the resources, the seabed itself, that are at the heart of the territorial arguments in that region.
So it's not just that the station happens to be located in a disputed zone. The actual subject of its core research, these potentially massive energy resources, is one of the main reasons the zone is disputed in the first place.
That's precisely the point the source highlights. It underscores how scientific exploration and resource assessment in this strategically vital, resource-rich, and contested part of the world are just inherently tangled up with geopolitical tensions, with competing claims over sovereignty and economic rights. Now, the article doesn't speculate about, say, potential military uses or assertion of control beyond the stated research aims, but by clearly noting the location, the contested resources, and the potential impact on the project's timeline. It definitely flags the geopolitical dimension as a major, maybe unavoidable aspect you have to consider with this project.
And again, just to be crystal clear, we're relaying the picture the source itself paints here, this complex mix of scientific ambition, cutting-edge technology, huge resource potential, and pre-existing international disputes, all converging on this deep-sea frontier project. The source presents this geopolitical backdrop as significant context.
Yeah, it's essential context provided by the article if you want to understand the project's full scope and the challenges it faces beyond just the engineering.
Okay, so looking towards the future then, the article kind of wraps up by bringing us back to that powerful initial comparison, Earth's final frontier.
Right. It circles back to that idea. Just like exploring deep space with amazing tools like the James Webb Telescope reveals cosmic secrets and reshapes our understanding of the universe. This deep-sea station, the article suggests, promises to unveil secrets from Earth's final frontier, these vast, mostly unknown oceans covering most of our planet.
It really elevates the deep ocean, positioning it as having a similar potential for fundamental discovery as outer space. And the article concludes by saying the world watches with anticipation. Why? Why? That specific word, anticipation.
Well, I think the anticipation comes from two main sources described in the article. First, there's the huge scientific promise, right? Think about the potential for truly groundbreaking discoveries in biology, geology, oceanography, chemistry that could come from having sustained access to extreme environments like these cold seeps. Finding new forms of life, understanding deep ocean carbon cycles and climate links, maybe learning about the origins of life itself, finding novel biochemicals. The scientific community worldwide would certainly be anticipating the data and insights that could emerge.
Makes sense. The potential for discovery is huge. And the article also adds that the project could potentially alter geopolitical dynamics in the region.
And that's the other side of the coin, isn't it? The other intertwined source of that anticipation, or perhaps, for some observers, apprehension. The possibility of making major scientific breakthroughs, and especially gaining new understanding of potentially vast resources in a place that's already highly contested. Well, that means this project isn't just about science. Its success, the knowledge it generates, even just its physical presence down there, could influence the strategic calculations, the economic interests, the legal arguments of all the different countries with claims in the South China Sea. So the world's watching not just for the cool science, but also for how it might ripple through international relations and affect the future of maritime territory and resource control.
Wow. Yeah, it's a project that seems to perfectly capture this convergence point between the absolute frontier of science, incredible technological ambition, massive resource economics, and really complex international politics. All these layers we've managed to unpack just from this one source.
Yeah, looking closely at this article really shows you how exploring the deepest parts of our own planet isn't purely a scientific endeavor anymore, if it ever was. It's happening within this global context of strategic interests, resource competition. It highlights just how interconnected all these seemingly separate fields become when a nation decides to push into a new frontier like this.
So thinking about everything we've pulled from the Sustainability Times article, here's maybe a final provocative thought for you, the listener, to chew on. If Earth's deep oceans really do hold secrets as profound as those we find by looking out at distant galaxies, and if access to those secrets, including potentially vast energy resources, is tied up in territories claimed by multiple nations, what does this specific deep-sea station project tell us about the future? About how scientific collaboration and international competition might play out in this race to understand and maybe utilize our own planet's last great unknown. It really forces you to think about what happens when that pure drive for discovery bumps up against the hard realities of geopolitics on a new extreme frontier.
That's a question that's definitely going to be debated for years to come, I suspect.
And with that thought, we've reached the end of this particular deep dive. We took a close look at the source material detailing China's ambitious deep-sea station plan, unpacking the incredible engineering, the potential science, and that complex geopolitical context.
Thanks for joining us on this exploration of what's going on beneath the surface in more ways than one.
Keep exploring, keep asking questions, and keep thinking about what lies beneath, both literally and figuratively. We'll see you on the next deep dive.